everyone. Welcome to my talk about how and why we went beyond the minimum viable platform at Coverwhale. I know it's pretty late. It's the last day of the conference, so I guess people are getting a bit tired. I'll try to keep you entertained, and I'll start with a few TLDR. So if there are a few key elements that I want you to take home from this talk, those would be the one. So who of you is a manager or not too technical? Nobody? Okay, one, okay. So one key element is switch to a CRD-driven approach as early as possible. What we mean by CRD is custom resource. So we want to represent what lives in your developer platform as a custom resource, as a document that describes in terms that are specific to your company what is in the cluster. The reason this is important is that when you go beyond the MVP, you are switching paradigm. During the MVP phase, so during the minimum viable platform phase, you are trying to build a proof of concept and demonstrate that having an IDP will provide value for the business. So usually you don't want to boil the ocean, and you try to go as fast as possible. And it doesn't really matter if you build technical debt, because anyway, if that phase fails, the technical debt will go away with your IDP. So you are not too much focused on that. But when you go beyond an MVP, then all of a sudden the focus switch. You don't build for short-term goal, you build for long-term longevity and long-term maintainability. So you have to stop piling up technical debt. And not having a CRD-driven approach is one of the key elements that will keep you create technical debt. So essentially, you should stop cutting corners at that point. You could do that in an MVP phase, but not once you go beyond the MVP. Second, it's pretty much related. Embrace the challenges that the developers push on you. When you are building an MVP, obviously you have to balance the bandwidth that you have with the expectation from the developers, and you can't take all of the use cases that you have in the company. You will just pick a narrow subset of use cases that the company has, and pick a few guinea pigs, build an MVP, and demonstrate the value. Once you have demonstrated the value, you will all of a sudden try to reach for a broader audience, like trying to reach ideally for the entire company. So you will have those challenges that will be pushed on you, and as DevOps, as technical people, we all have opinions, and you will push back against technology that you don't like. But at the end of the day, developers are the ones that are going to live with your platform, and they are the ones that you have to convince to go in the platform. So embracing the challenges that they push on you is a key factor to drive user adoption, and that's ultimately what you want to achieve as a platform engineer. And last but not least, this one is not only about when you go beyond an MVP, but it's also valid during the MVP phase. You can't skip supporting secrets in your platform. Really, you can't skip it. It's very important. If you skip supporting secrets, developers will need to use secret, and they will use it in a way that might not be the best. Some might not. So you'd rather have that in the IDP so that you don't have to worry about our secrets handled correctly. And even proving the concept, you have to have the secret supported. So I'm Laurent Sibilla. I'm a platform engineering consultant. I help companies to build IDPs. I'm a Kubestronaut also. I'm available on LinkedIn. Don't hesitate to connect with me. I'll be more than happy to stay in touch. I'm also available on some Slack workspaces like CNCF, platform engineering workspaces. But I'm a bit less active than on LinkedIn. So the agenda for this talk, introduction is done. I'll speak about the MVP journey that we did, the limitation that we found out after the MVP was fully rolled out, and then how we overcame those limitations and went beyond a simple MVP. Hopefully we will have time for Q&A. I'll try to not sidetrack myself too much so that we have a bit of time for the questions. Okay, to set the context. So this story happened at a company that's called CoverWhale. You probably never heard of CoverWhale. They are only operating in the US. It's an insurance company for truck drivers, or truck transporters. They have this product called DriveSmart that is just focused on teaching the drivers to be better drivers and have less accidents or less claims and better profitability for the insurance. They have been established in 2019, and in 2024, 2025, when this story happened, they were viable. They had proved the viability of the company, and they were scaling up, and they had like around 40 developers. So that gives you a bit the scale of the engineering team, and maybe can help you relate to your particular experience. They had this PV2 project. So they're not very innovative with name. PV2 means platform V2. So they had this insurance platform that they had built, the founders of the company had built. It was PHP Laravel based monolith application, and it had piled up technical debt since the foundation of the company, and it kept running it. And just to give you an idea, they were using a PHP version that was like 2 or 3 years out of support, so a lot of technical debt. So much so that they did not have a nice way forward to move to a more modern architecture, so they decided to do a complete rebuild with the V2 of the platform using Golang and NATS-based communication. So NATS is a messaging service bus, does persistence and so on. I speak a bit more about NATS later on, but it's not too strange for you to hear that right now. And we could foresee around 20 microservices. So for us, as part of the DevOps, SRE, DBA, pretty much everything, we did cloud and so on, so we had only 2 people. As I said, it's a small company, you have 40 developers, you can't have an army of 10 cloud engineers. But seeing 20 services coming up with a team of 2 people handling a lot of stuff on the side, it felt a bit like a challenge. Like we had on the left side, on the left side here, a monolithic application, one single pipeline, simple infrastructure, one single VM. We handled it by hand, manual operations. All of a sudden, we move here with a lot of services, a lot of pipelines, a lot of infrastructure as code, Kubernetes manifest. We were not ready to handle that at scale, so to say. So it felt like it was the right moment to start building a platform to have a more scalable approach. So we built the MVP in a few weeks, 6 weeks, 8 weeks, something like that. We reused an AKS cluster that was already there. So we tried to be as efficient as possible and reuse what was already there to build the platform. So the AKS cluster was there. We had the possibility to deploy Helm charts. So we deployed the elements of our platform using Helm charts, deployed by Argo CD, and we also used Argo CD in combination with Helm charts as platform orchestrator. So that was the main brain, so to say, of the developer platform. We had ACK for deploying AWS resources using Kubernetes resources so that we could, with the Helm charts that we have in the platform orchestrator, deploy resources in AWS. It was mostly IAM roles, IAM policies, container registry, so it was quite slim, but it allowed for future improvement. For the developers, they would just create an application manifest. We had a structure of workloads, like workloads were gathered in system. System belongs to a team, and with those manifests, we could represent somehow all the services that we had in the company and assign it to teams. And it would translate automatically using Helm charts into resources in AWS, in the Kubernetes cluster, resources in Route 53 with external DNS and things like that. For the developers, they had port.io as developer portal, so they could see, we could surface all the things that were happening in the IDP in port.io, and they could start having self-service action. It was very minimalistic in the MVP phase, but we could expand on it later on. From the developer's perspective, the usage of the IDP was pretty straightforward. So they had their local environment, like you could expect. They could code there, and we just expected from them to have a makefile. The makefile would describe how to test and build the application, and then we would use CI/CD, GitHub Actions with standardized CI/CD that would just rely on the test and build processes defined in the makefiles. The pipeline would run the test, trigger the run of the test, build the image, version it, so provide a version number that's semantically, semantic versioning compliant, push it to an artifact registry, tag the version, the source code, the Git repository with the version of the artifact, and then it would inject the version number into a GitOps repository that will be taken by Argo CD, reconciled into the cluster, and so with minimal effort from the developers, but a lot of mechanics on the developer side. On the IDP side, we would have a live environment, the dev environment with the new version of the code that they just pushed. Then once they are happy with the dev situation, they could stage the artifact to higher, they could promote it to higher environments using port.io, so they could promote to test when they are happy, UAT, production, and so on, eventually until production. So this setup was pretty satisfying. We were pretty happy with it, but we had a few limitations that was blocking us to go further. First, Helm is quick and easy to set up, especially with Argo CD already set up. The cluster was already there, so it was a good idea for us to start with that. But it scales very badly. All the features that you have in your IDP are going to land in different places of the infrastructure. So if you look at your Helm charts, you have Helm charts at the system level, at the workload level. Some are deployed alongside Argo, in Argo CD, in Argo CD namespace, or the platform cluster, and then you have some that are deployed with your workload. And so you have one feature that is scattered around a lot of different folders, and just working on one feature feels like constantly switching the repository and so on. It was very cognitively heavy, so to say. Also, Helm is text templating. I won't speak about it. I have heard a lot of speakers speaking about it earlier. Everybody hates Helm. But for us, the real showstopper, what prevented us to keep going that way, was it doesn't allow advanced orchestration. What I mean by that, you can't deploy a resource, an IAM role, for example, retrieve an output, the ARN, and then inject it to your pod identity. Things like that can't be done with Helm charts. So we had to find another way. You could still trick around according to specific situation, but you don't have one solution for all those use cases. Second, we had a loosely defined front-end back-end interface. What I mean by that is that we could not have port.io just read resource and surface it. We had to trick around. We did not have CRDs. I get back to what I said during the TLDRs. So we had to trick around and have Argo CD resource and labels, resource labels and annotations to surface that information. But it was a bit tricky to get it right. You should avoid duplicates, and just not going into too much detail, but it was tricky. And finally, DevX was becoming an issue. So NATS became a predominant piece of infrastructure, and we did not support it. And developers wanted it, even if we pushed it back. I'll get back to that in a moment. I need to speed up a little bit. So there was some deficiency in the infrastructure. So as I said, we reused infrastructure that was already existing. We knew those issues from the beginning. We just decided to go for the MVP, knowing that we would have to eventually rebuild the infrastructure that was behind the IDP itself. We did not have good environment segregation, not a dedicated platform cluster. We observed the cluster from within the cluster, so if the cluster dies, we can't know why it died. Didn't feel good. So we had to rebuild stronger foundation. So, going beyond the MVP. Dev wanted to have NATs, despite our pushback. It provides a lot of interesting features, but for us, it did provide a lot of challenges. It relies on a SaaS platform, so they were using Sign in the Cloud. Sign in the Cloud didn't have an operator for Kubernetes. It didn't have good integration with any kind of tool, actually. The API was not well documented. I know they improved since then, but back then it was not really well documented. But from the developer's perspective, they don't really care about all those integration issues. They have a very attractive platform in NATS. It provides message queuing, retry, persistency, low latency, and you name it. I won't make a full presentation of NATS, but it was very interesting for them to use it. And remember, we are building Golden Pass, not Golden Cage, which means that they could just, by themselves, support NATS. And we even went as far as providing the virtual machine, monitor the virtual machine, because they needed a virtual machine for leaf nodes, whatever that is. It's not very important here, but yeah, they did. So they supported it, and the intention was to go all the way to production with that, which was a bit scary for me. So at that moment, I was alone. The other guy from my team had left. And how do we ensure that the setup that they have in dev is going to be reproduced in production? It was a lot of ClickOps. So they went to Sign in the Cloud platform, created a new service, provided a permission, a lot of manual operation, not great for reproducibility. Also, what about the operation model? If it breaks in the middle of the night, well, even if I said I won't support it, I will be waking up anyway, and I would have just to escalate to them. So I didn't feel great about that situation. So in a nutshell, NATS had to be part of the Golden Pass. So how do we do that? So I wanted to introduce a CRD-driven approach so that we could represent things in the IDP as they are, so to say, and then have a reconciliation loop that would reconcile what we wanted to have with NATS, and not just specifically for NATS, but just having an operator that would reconcile what we want to have with what is actually deployed. Wanted to have feature-oriented code structure, so in this operator, we could gather features in a single Docker image and have everything in the same place, even though it's distributed in different parts of the ITP, and also avoid text templating because we could pick the tooling of our choice. But building an operator is pretty scary, especially when you are alone on your own and you have a lot of other stuff to manage. So it was a bit too high effort. I really wanted to find another alternative. And this is where my team lead suggested that I looked into Kratix. And Kratix it felt like was striking the right balance between being agnostic and providing, solving for you all the reconciliation loop, the CRD lifecycle, and so on. So essentially, you have just to provide the procedures to create resource, delete resource, update it, and all the CRUD lifecycle, so to say. And it manages the integration with the cluster for you. So it felt like the right approach. So I decided to first build a small proof of concept of using Kratix the way we wanted. I had one issue at hand that could be a good fit for this proof of concept. We had several teams creating APIs, and up until now, we just had a gateway API in in AWS, and people would just update it by hand and with some processes to have a minimum of governance, but that was about it. So I wanted to have an automated process, so they could, in their application manifest, say, I have an external API, I want to publish it to this endpoint, and it would, all the APIs would be shown into a unified domain under api.coverwell.com, so that we could decouple the external perspective of our partners from our internal organization. We wouldn't have like different domain and so on per team. The proof of concept was very straightforward. Like it took literally 2 days, I think, to get that production ready. I was pretty happy and decided to start tackling the support for NATs. The idea was to, so I didn't went into too much detail into the API aggregation mechanism, but it's a bit the same as here. We have, so this is the only code I've shown up in it now. We had an application manifest that looked like that. So just simple application, all the specification about the teams and whatnot. I added a section called NATs, where I could just add the topics that you want to allow and deny eventually to publish and subscribe. And then transparently, the IDP would create a service user. It would assign permission to the user, create an access token, create a Kubernetes secret out of it, bind the Kubernetes secret to the environment variable of your choice. And then, I mean, at that point for the developers, it was feature parity. They did not have to go to the Synode cloud anymore. As a transition period, we decided even to remove access to Synode cloud from the developers so that we were sure they were using that mechanism moving forward. And everybody was happy. Life was easier for them. They did not have to worry about reproducibility and so on. We had control. I felt better. And we could go one step further because all this mechanic is automated. So you could have token rotation, which developers didn't really want to do by hand. Go in Sunny the Cloud, create a new token every month, felt like not so great. So we just added an expiration date to our token, and then when the expiration date was closing in, we would just create a new token, and we had a reloader that would automatically perform a running update. So everybody was happy. We had a better security posture. Developer had an easier way of managing NATs, and I felt like everything was under control. But as I said, secrets is tricky. And the way Kratix works, you have to bring your own GitOps agent. So you see where this is going. The secret that you produce with Kratix is saved into your GitOps repository, which is something you don't want to do. So we solved that using sealed secrets. So when we provision the cluster, we create a private key, public key. The public key goes into the platform cluster. The private key is stored and forgotten, but stored in the workload cluster. And Kratix would generate the secret, save it, generate the secret, encrypt it, save it, and then it's loaded into the workload cluster. So as a conclusion, I'm right on time, I'm pretty happy. As I said at the beginning, switching to CRD-driven approach helped us to manage the life cycle of NATs, and I wouldn't be able to do that without the CRD-driven approach. We had a better structure of code across different features and different places where the features act in the IDP. We have embraced challenges that developers had, which helped to drive user adoption. So that IDP is used across the company now, except for PV1, which is considered a snowflake and is going to die at some point, so we just let it die. And yeah, supporting secret had its own set of challenge in the MVP phase and had another set of challenges in when we went beyond the MVP. So thank you very much for listening. Please write me. I would be more than happy to hear your feedback on this talk. And if there is any question, I think we have 5 minutes. Okay, thank you.
Are there any questions? Okay. Thank you very much.
Thank you.